All right, so today is October 4th, and our lesson for today is about the fraction decimal relationship. So you're going to title your own fraction decimal relationships.
Oh, I was thinking about something else.
You might be thinking about this because,
FTPs.
yes, FTPs. We really value the ability to flow between number forms. So today we're going to look at taking fractions and changing them into decimals. This is review, but there are a couple things kids frequently forget. And then I'm going to show you one new thing which should help you out and be kind of interesting to you. So let's start out with how we can change a fraction to a decimal. How can we change a fraction to a decimal? There's two things we can do. And we want to look at both because you need both skills really. Barry? That's true, and that's the second way I want to look at. So we're going to come to that in just a moment. First way is a little bit easier if you can do it. Any ideas? What's another way we can change a fraction to a decimal? Like say perhaps a fraction 2/25. Change 2/25 easily to a decimal number. Ideas? Daryl?
We just find how much it is out of the 100, and then it just it's very much
Decimal, because our decimal system is based on that. Yes, that's the first and easy way of doing it. First option you should look for is, can you change the denominator, I'm going to abbreviate denominator, of the fraction to a power of 10. I want us to think about what we mean by a power of 10. Daryl gave us a power of 10 already. Daryl, you said change it to what value? 100. 100 is a power of 10 because it's 10 to the second power, right? 10 to the first power is 10. 10 to the second power is 100. What's 10 to the third power? Robbie? 1,000. So these are all what we would call powers of 10. 10, 100, 1,000. Because we get them by raising 10 to a power. So you first check, can I change the denominator to a power of 10? And my example of, you know whether I said 4 or 2.
I think it's 2/25.
I changed it to 4 now. Sorry. 4/25, Daryl said, yeah, I can turn it into 100. What do we multiply by to turn this into hundredths? Mikey?
4.
We multiply the denominator by 4, but what else do we have to do?
Multiply the numerator.
Yeah, we have to multiply the denominator and numerator by 4. This is just really important for your number sense, like why can we do this? Well, what is 4 over 4, Liam?
That is,
Now what is this?
oh, that's 4 over 4.
What's just 4 over 4 equal to? The latest?
1.
1. So we're basically multiplying this number by 1. Does that change its value?
No.
No, that's why we can do it. It's the same number, just dressed a little differently. What is it turn into, Liam?
That is 16 over 100.
Right, which we say properly as what, Liam?
16%.
Oh, well, that's true. But if you read the denominator, you say 16 hundredths, yeah. Which is 0.16, which is what Daryl was saying. You write it, and then you can just put it as a decimal because of the decimal number system. Yeah, Luke?
It's not simplifying, it's intensifying.
I guess that's one way you could look at it. Instead of simplifying down lower, you're intensifying it. Okay. This is for your sake. If you don't remember the place names, you really need them to do this. So just really quickly, I know a lot of you know this. This place in front of the decimal place is, of course, the ones place. What's this place, first place after the decimal point? Vaishu? Tenths. Don't make the mistake of calling it the ones place. There's no ones place. Tenths. After the tenths place we just used is what, Mary? Hundredths. And after the hundredths place, Mikey?
Thousands.
Thousands. What's the one after the thousands place? What's the one after that called? I'm standing in the way. Will?
10,000?
Yeah, the 10,000th place. And it would keep going on. You gotta know those place values in order to be able to convert these fractions to their decimals, right?
Wait, is there like a billionth thing?
Billionths place, yes.
Weird.
But you don't really
100,000.
read it that way or say it very often. But yeah, there is.
100,000 and millions.
10,000s, 100,000s, millions, 10 millions, 100 millions,
Billion.
billions.
And then after
trillion.
billion.
All right. Okay, so that easy way, if you can do it that way, do it that way. All right, let's move on. The other way Mary mentioned. All right. The second way you can change a fraction to a decimal is to divide. All right. This fraction is also a division problem. You should know that the fraction bar, my arrow point is off, means divided by. This is 5 divided by 18. 5 divided by 18. But I find that the real issue here comes in when kids set up their long division. You gotta make sure you put the right number in the division box as the dividend and have the right one as the divisor. Where does the 5 go? Where does the 5 go? Real?
Inside the box.
Inside the box, it's the dividend. And the 18 goes outside of the box.
Oh, I like this.
The wrong way. Now, lots of kids do, in fact, put it in the wrong spot, and I've got just a stupid little story for you that might help you remember if you have a hard time. In math land, just like in the real world, it should be illegal to stand on another person's head. 5 is standing on 18's head. That has got to be illegal, and 5 should definitely get thrown in jail. The stander on the header goes in jail because that's naughty. The other one is looking inside saying, "Nanny, nanny, boo, boo, don't stand on my head again." All right, is it a stupid story? Yes. But will it work for somebody?
Yeah.
Maybe. All right, Will?
Another thing that you could use to check, if you put 18 inside and divided that by 5, you get a whole number.
Yeah,
Which
and that's
you don't want.
exactly, Will. That's the mathematical sense of it. We know 5/18 is less than 1 whole. So when I set up my division, I should better be getting a number that's less than 1 whole. Yeah, right, good. All right, so then we divide. Do you have a question, Luke?
Is your arrow pointing to the 5 or the 18?
The divided by the divided by?
Yeah.
It's supposed to be pointing to the fraction bar. The fraction bar means divided by. All right, so we divide. There's no decimal out here by the 18, so we just start dividing. We put our decimal place up, and we say, all right, I'm wondering if there is a group of 18 in 5. No. What about in 50? How many factors of 18 are in 50? Mikey?
3. Or, no, 2.
2. 3 is a little bit high. 2 gives us 36.
Oh,
And
yeah,
we
yeah.
subtract, and we get 14. We got to keep going. All right. How many times 18 into 140? I'm not even sure off the top of my head. I'm thinking. What do you think, Daryl?
7.
7, I think it is right. 7, 56, 35, 126. Good. I subtract. I get 14.
Oh,
So it's 0.27 repeating.
Oh, yeah. Those 7s are going to nice keep repeating. I like that. How do I write the answer? 5/18 is equal to 0.27. You put a bar, a repeating bar, over whichever digit or digits repeat. If the 27 was repeating, 27, 27, 27, then you would write it like that. But in this case, it's just the 7 repeating, so you just put it over the 7. Yes, Will?
Isn't that barcode the vinculum?
Yeah, you're kind of good in memory, better than me.
Remember?
That's great, yeah.
Oh,
All right,
thank you, Mom.
all right. So that's how we change a fraction to a decimal. If it doesn't go to a power of 10 easily, we just divide. All right. Now, for something new and interesting for us.
Bum bum. Bum bum. Bum bum bum.
Okay. We don't need the music. We just need the smart board to work. All right. The first one we did end it. It was a terminating decimal. The second one we did repeat it. And it's really helpful actually when you're looking at a fraction to when you look at it, just by looking at what the denominator is, we can tell whether that fraction will turn into a terminating decimal or a repeating decimal. And that comes in handy as we start to divide. If we know it's supposed to repeat and it's not repeating, we know we're doing something wrong. So let's look at that. How can we tell if a fraction will be, I'm only standing right back to you, Anna, will be a terminating, which means ending, it just stops. A terminating or repeating decimal. Well, there's a clever little way, I think, to find out, and we're going to do some investigative work and see if you guys can figure it out, all right? So I am going to list a set of fractions up here that I'm going to tell you are terminating decimals, all right? Let's see, what else do I want to do? Those. All of those fractions, if I made you convert them all right now to decimals, would be terminating.
Do we have to?
Decimals. Ones down here are going to all be repeating decimals.
Well, I don't know what you're terminating or.
Well, a terminating decimal is a decimal like 0.14. It's just a terminating decimal. It ends. 0.14 is a terminating decimal. These ones down here are going to be repeating decimals, like 5/9, the decimal that repeats 5, 5, 5, 5, 5. So there's a way to look at just the fractions and determine whether they will become a terminating decimal or a repeating decimal.
Wait, so the up top ones are terminated?
These ones are going to be terminating, and these ones down here are repeating.
I didn't know what the top your head.
I'm going to teach you so you can figure it out too. And let's go with, I think that's enough. Okay, so here's what we're going to do. I'm going to have you prime factorize the denominators because the denominators are key to solving this issue. All right? And I'm going to assign you and your partner one to do. And then we're going to look at the prime factorizations and see if we notice anything about the repeaters versus the non-repeaters. One thing that's cool about this is it allows us an opportunity to use our prime factorization skills and review them right now. So let's take 3/40ths. I'm going to have you and your partner look at the factors of the denominator. I want you to look at the prime factors of the denominator. So recall for me what I would do to find all of the prime factors of 40. What do I do? We learned this last month. Michael?
Index notation.
You can find index notation, but what do you got to do first, Michael? But how do we get to that stage? What do we do? What's that? What do I want to do with this 40 to get to the index notation? You don't know? Mary? Yeah, and how do we get that? What do we do right now to get it, Daryl?
Inverted division.
Inverted division. We got to do the inverted division, right? All right. Good thing we're reviewing. What's the prime factor of 40, Caitlin?
2.
2. Goes into the next 20 times. Can you think of another prime factor of 20, Mike? 2. 10 times. Can you think of another prime factor of 10? How about Daryl?
5.
How about some other people getting engaged in class? All right, these are all the prime factors here, right? So I could write it in index notation, like Michael Lloyd said. But for the purpose of our investigation, I just want you to write it out long form. So 40's denominator is 2 times 2 times 2 times 5, right? I'm going to assign you one of these other fractions where you and your partner are going to prime factorize the denominator. I want you to come up here and I want you to write it without index notation just this once. Okay? Are we clear? All right, so let's start assigning. Mary and Luke do 32. Logan and Liam do 16. Jack and Aaron do 250. Okay? Harold and company do 72. Prime factorize 72. Will and Vice do 90.
Wait, did we take off the 0.5?
Robbie and Mike do the prime factorization of 26.
Did we erase?
You do 98.
Wait, so
Did we erase 0.5?
Yeah, that was just an example for me to tell you what I was talking about.
Okay, just one part. Did you say we don't prime factorize? Okay, so we do it.
Okay, so we've prime factorized all the denominators. We're looking to see if there's something special about these ones here that terminate as decimals versus these ones that repeat. Some people have their hands up, they see something. Well, people did have their hands up. Did they change your minds? Liam? Anything special up here?
Everyone.
Logan, can you please stop? Robbie?
They're all two.
Yeah. Up here, the ones that terminate have only factors of 2's and 5's. When you look down here, what do you start to see popping in here? Caitlin?
3,
3,
7,
7, 13.
Oh, 30.
Anything in addition to or besides 2's and 5's. If you look at a denominator like 72, and you know it has 3 as a factor, this is going to be a repeating decimal. So if you have to change it over, you should know right away it's going to turn into a repeating decimal, and you should be looking for a repeating block. These ones up here, if the only factors are 2 or 5, 2 and or 5, it'll be a terminating decimal, and you should expect it to be ending. Caitlin?
so repeating is anything that doesn't have 2 and 5 will both in the same.
No, it could have 2 or 5, or 2 and 5, but as soon as it has something else along with it, then it's going to become a repeater. Jack?
What if it's something like 36, 70 seconds because you know it's half?
That reduces down to 1/2, so you got to look at its simplest form.
Oh.
That's a good question, Jack. Yeah, its simplest form fraction. All right, let's summarize that on a new screen. Or actually, I'm not going to, well, I'm just having one issue after another here. So I'm going to just erase, all right? You guys have this stuff down? Okay, so let's summarize that.
I still see it.
Yeah, I guess what's
Well, that's weird.
All right,
Oh,
so a fraction.
Whoa, that is scary.
Oh, so I'm not the only person who sees that.
Okay, guys. Fraction will become a terminating decimal. If the denominator, I'm going to abbreviate denominators, factors, should say prime factors, are only 2's and or 5's. So you look at that denominator, and if it's only got 2's and 5's, it's going to be repeating. Terminating. It's going to be terminating. Repeating, on the other hand, the denominators will have factors other than or in addition to 2 and 5. As soon as a 3 or a 13 or a 7 or an 11 shows up as a prime factor in the denominator, it's going to be a repeating decimal. we're gonna practice.
Wait, is this on a homework?
Yep, so yeah, you gotta know it. Alright, so, somebody think of an example of a fraction, not a lame one like fifths or tenths, that they know is gonna be a terminating fraction. Terminating fraction, and a reason why you think so. Alright? Luke?
984,566 million.
Yeah, but that's, that's a power of 10, so that's really straightforward. All right? Why don't we do this? I'm going to pause for a second, and I want all of you in your partner group to think of one fraction that will be a repeating decimal, and one that will be a terminating decimal based on the denominator, and try to get something interesting, not lame.
Alright,
I don't want to go back down.
Will, you have an example. Which are you going to give me?
repeating,
Okay, what repeating fraction are you going to give me?
796.
7/96. How do you know that's going to be repeating?
Because I thought of 32 would be a good terminating, so I multiplied that times 3 to get me a repeating.
Okay. Another way you could just look at 96, right? What's the sum of its digits? What's the sum of 96's digits? Caitlin?
15.
15, and I know that 3 is a factor of 15, so this has got to have a factor of 3 in it, so Will is right. This is a great example of a repeating fraction. As soon as it has a 3, or a 7, or an 11, or a 13 in it, it's going to be a repeater. All right, what do you got, Robbie?
Can I do it?
Sure.
It's 6 over 7,392.
6 over 7,392. That's a crazy number, Robbie. How do you know it's going to be a repeater?
Because I added up all the digits to the denominators to the 1, 3,
Yep, the sum of those digits is
21.
21. So yeah, it's a crazy one, but yeah, he's right. It's got a 3 in there, so I know. It actually could be reduced too, because we know 3 is in the numerator as well, right? All right, now I don't want any more crazy ones. All right, I just want something else. All right, what you got, Caitlin?
1256 for terminator.
1256. Let's take a look at it for terminating. What are the prime factors of 56? What are two numbers you can multiply together to get 56, Caitlin? Any two numbers? Multiply together to get 56. What do we multiply together, Anna?
28 times 2.
28 times 2, okay. But you gotta keep breaking down, what do we multiply 28 by? What are factors of 28? What multiplies together to give us 28? Mikey?
14 and 2.
14 and 2. So far I'm seeing factors of 2. What does this have in it as a factor? What does it have in it as a factor, Caitlin? 7. Yeah. You see that 7 showing up? As soon as I see 7 as a factor of this number, I know it doesn't belong up here, it belongs down here. Do you get what I'm saying? Yeah? Okay, Daryl, you had a question?
Actually, I think I'm trying to answer it, but is it okay if, like, with 1256 in there, we can simplify the 3/14ths and then try to find,
Yeah,
so that's what it is.
yep. We need a terminating one. Got a terminating one for me? Because this one belongs down below. Mikey?
Well, I'd really give a repeating one.
Okay, I want a terminating one. Jack?
137, 250th.
137, 250th.
Thank you.
Right, and a quick check is I know I can get this by 25 times 10, right? And 25 is 5 times 5, and 10 is 5 times 2, so it's only got 5s and 2s in it. Yep. Logan?
7/15.
7/15. Where does 15 belong? Does it have anything besides 2s and 5s in it?
It has 5. Oh wait, no, it has 3.
It has a 3 in it, so that would go
7/20.
7/20. Yes. That's 2 times 2 times 5. All right. Luke?
97/100.
Yep, 97 100s. 100s is that, most of the time you can just see that. What about this one, you guys? What about 11/16. What about 16? What are the prime factors of 16? Factors of 16. Anna?
4,
Prime factors, so go further, break those down even further.
2,
2 times 2 times 2 times 2. It's all 2, so it works. It's terminating. Right, you get the idea?
Oh, I understand.
It's all just 2s. And or 5s.
Twos and or five, I thought it had to have two and.
No, good point to clarify before we turn this off. This says that it has to have, its prime factors are only 2s and or 5s. It doesn't have to have 2s and 5s. It can have just 2s, just 5s, or a combination of
Students
them.
rather, please approach the front office. Catherine Walsh.